Hello and welcome to the second part of the ABB drive ACS310. So in this video, I will show you the working demonstrations, practical working. So in the first video, I'll explain the manual of the ACS310 drive. As you can see, we have two drives here, one drive and two drives for the two fans. Okay, and we connected through a Cat6 cable display on the top of the panel. So this drive for the first one and this is for the second. So in this video, I will show you how we can connect this drive, how we can give a command or we can monitor the drives, the motors in the BMS also, and how we can change the value, how we can manipulate the values from the field side also. So let's start. So before going to the demonstration, practical demonstration, first I will show you some of the parameters what I explained in the manual part. So let's come here. So as you can see the screen here, it's showing remote. As you can see the remote over here. Remote means we are not able to change the value from here. See, once I press the start, nothing will work. As you can see over here. Okay. So remote means we have to give the command from remotely, from either from the BMS or from the its digital input pins. So if you want to switch to local, what you have to do, just press this local button once. Once you press, it will display a message LOC local, and now you are in local. As you can see here, now it changes to local. Okay, and it's showing 0 Hz. Now what I will do, just press enter and go to reference mode, REF reference, and just press enter. From here you can change the value. Okay, you can change the frequency. Okay, output frequency means how much speed you want to run your motor. So I'll make 15. As you can see in the meter also, meter itself, now we have 0. Now we have 0 means all the currents are 0. Okay, each phase have 0 because the motor is off. So now I change to 15 Hz. So once I start the motor, it will consume the current from here. So and also you will get this indicator run. Okay, so just I press start. As you can see, it is started and also it starts consuming the currents. Okay, so in this way, in the local mode you can turn on or turn off the motor. So now I turn off the motor, and as you can see over here, the current is going to be 0 and the stop indicator is started. So again, just go to remote. So just press remote button once, you will get remote. Now you are in remote mode. So now you are not able to run the motor in local mode. Okay, so in remote mode we have two options. Either we will run it from the BMS, okay, or from the SCADA system, or we can run this one by we can run this from its digital inputs. Okay, so let me explain you some of the parameter. So just press enter, go to parameter. Okay, from the parameter, see there is a lots of parameter group. I already explained this group in my part 1 video manual, ABB ACS manual. So just go to parameter 99. In the parameter 99, the parameter 9901, as you can see over here, the parameter 9901, we will set the motor data in parameter 19. Okay, so in 9901, it will show the language. Okay, it is shows the language. Which language do you want to select? Once you press enter, it's showing 0. 0 means English. Okay, in 9902, as you can see over here, 9902, we have to select the application macro. There is lots of application macro like ABB standard, 3-wire, alternate, motor potentiometer, auto hand, PID, PFC, SPFC. Okay, so in this we have selected auto hand. So once I press enter, you will see a 5. 5 means there is application macro, auto hand application macro is used. Okay, next 9905, you have to select the motor nominal voltage. Okay, in our case, you can see 380 volts. Okay, so our motor is a 3-phase motor, so it's the input supply is 380 volts. Okay, so 9906 is the motor nominal current. In our case, 6 ampere maximum current consumed by our fan. 9907 is the frequency. As you can see, 60 Hz. 9908 is the motor speed, which is 1700 RPM, and 99014, this is the phase inversion. Okay, now by default it's 0. When the motor will run in reverse direction, if you want to make it forward, just go to 9909914 and make it 1. So your motor will change the direction without changing the cables. Okay, so this is parameter 99. Now in parameter 14 we can, in the 14 we will set the relay, because in ACS we have one relay. So in 14 parameter 1401, let me show you the relay in the ACS drive. As you can see here in the ACS drive, there is one relay, that is 17, 18, 19, and there is one transistor output, digital output. We can use that one as a transistor output, or we can use as a pulse frequency also. So in the ACS310 drive we have one relay. So if you want to configure the relay, you have to go to the parameter 14. So let me explain you the parameter 14 also. In 1401 you have to select the relay output. Okay, so which purpose you want to activate your relay. Like either if the motor will run, then you want to activate, the motor will stop, then you want to activate, the motor is tripped, then means you have to select the reason why you want to actuate your relay. So in this case, for my case, I have actuated this relay when the motor will run. When the motor is running, the relay will actuate it. So in the BMS I will get the feedback that the motor is running. Okay, because we have a BMS. In the BMS we can check the motor is running or off. So by this relay we will get the feedback the motor is running or not. So if you want to make this relay for run status, you have to set for 1401 as 2. As you can see, it's 2 means run status. If you want to make this relay for the trip, you have to go for 3. So just go to 1, press enter and make it 3. Once you make it 3, then this relay will actuated by default. Now 9902. Okay, in 9902 we can set the relay output second relay. Okay, because in the ACS310 we can install a relay module, extension relay module, if you want more relay. So but in my case we don't have any extension relay module, so we will not set the other data. Okay, now we also have a pulse output, which I will use as a digital output pins. Means when the motor will trip, due to any reason, I want a feedback. I want in my BMS that the motor gets tripped. So if you want to set that, you can use the parameter 18. In the parameter 18 you can use. In the parameter 18 you have to use the other digital output pin. Means there is a transistor output. So if you want to use that one, you have to go to parameter 18. Okay, in parameter 18 go to parameter 1804. In the 1804 you have to set whether you want to use that transistor output as a digital output or the frequency. So if you want to make its digital output, you have to make it 0, otherwise you have to make it 1. So in this case it's 0. 0 means I want to use this as a digital output, not as a frequency input. Okay, so after that in 1805 you have to select the reason when you want to make this transistor output to be actuated. Okay, so in this case the first relay I have used for run status, but in this case this relay I will use as a fault. So in fault it must 3. So as you can see it's already set to 3. So 3 means when my VFDs get stripped, that's this the transistor output will get actuated. Okay, so this is the basic data you have to enable, you have to set in the VFD. Let me talk you the wiring. Let me talk about the wiring also. So just check the wiring here. So as you can see, the terminal number here 1 2 3 4 5 6 7 8 up to 8. Okay, in which each terminal is used for a specific reason. Okay, so like the terminal 2 and terminal 3 are for analog input 1. This is the analog input 1 and this is the ground for the analog input 1. Okay, the fourth number is a 10 volt supply, 5 number is analog input 2 and 6 number is the ground for the analog input 2, 7 number is analog output and 8 number is nothing but ground for the analog output. Okay, now the 17, 18, 19, this is the relay. Okay, one relay, and behind this there is a 3 terminal, that is we can use as a either relay or frequency input. The terminal number is 20, 21 and 22. So for this relay I used for run status. Okay, when our VFD will run, the motor will run, the relay gets actuated, and when the VFD is stripped, this B side there is a one more transistor output relay, it will get actuated, and I will get the alarm in the BMS that the motor gets stripped. Okay, after that there is a pin from 9, as you can see, from 9 to 16 there is a pin in which 9 is the 24 volts, 10, see this 10 is ground, and this 11 is the common for the digital pins. These digital pins are, there is 5 digital pins, 12, 13, 14, 15 and 16. Okay, so this is the terminal details. I already explained this terminal details in the manual video in the part 1, and also these two, as you can see, these two are for like a dip switch, through which you can decide that for the analog input whether you want to you want a 0 to 10 volt as an input or 0 to 20 milliamps. Okay, and these two are the termination resistor when you are using the Modbus, because these 23, 24, 25 and 26, these 4 terminals are used when you have a Modbus RS485 communication cable. Then you have to connect this terminal with the other VFD, and then at last you have to connect it to the PLC or the BMS system. Okay, when you want to use a Modbus protocol or RS485 protocol is. Okay, so in this case, as you can see, this 2 and 3 is the analog input through which we can decide the speed of the motor. Okay, if we apply 10 volt here, okay, if we apply 10 volt here, the motor will run up to 100% speed. Okay, means 60 hertz frequency. If you apply 5 volt, it will run half, and if you apply 2.5 volt, it will run 25% speed. So you can decide the speed from here. So as you can see, we have connected 2 cables, 1 and 2. So 1, 2, as you can see here, it's connected over this TV, 1 and 2, and from this TV, this wire is going to our BMS. Okay, these 2 cables are going to BMS. Means from the BMS we will apply 0 to 10 volt. Okay, and here the 2 terminals 7 and 8. This is nothing but the analog outputs through which we can see the feedback. The motor is running from the BMS. We can check the feedback. The motor is running with 100% on 50%. So as you can see, this 7 and 8, these are connected over here. As you can see, 7 and 8, and there is a 2 cables connected over here. This is also connected to our BMS. So we can read the speed from here, this cable, these 2 cables, and we can give the command and the speed from these 2 cables. Okay, this is the relay. So as you can see, in this relay there have a cable connected to 17 and 19 terminal. Okay, and as you can see, when this relay gets actuated, when these 2 relay gets actuated, it will trigger this relay. Let me show you the relay. This relay. Okay, as you can see, in the 17 we have a phase. Okay, if it's visible or not, I don't know, but there is a current over here. So when this relay gets actuated, when the motor will run, what it will do? It will transfer this phase to the 19 terminal. Okay, and we connected a cable that is 9 number, and this 9 number will trigger this relay. As you can see, we connected a 9 number over here. So when this relay gets actuated, we have connected also 2 more cable over here for the BMS. This cable 7 and 2. Okay, this 7 and 2 we have connected to our BMS. So once this cable gets become NC, it will show in the BMS that the motor is running or not. Okay, this relay I have used for a trip. When there is a trip, as you can see over here, when it's get tripped, okay, we'll get a 24 voltage through this 8 number wire, and this 8 number wire is connected to this relay. When we get a 24 voltage, this relay will get actuated, and it will make this cable 20 and 21, it will go to NC. As you can see here, 20 and 21, it will become NC, and this NC is connected to our BMS. So in the BMS we can see whether our VFD or our motor is get stripped or not. So this 1, 2 is for command purpose. This 4, 4, I will explain this 4, 4 later, and this 20 and 21 is used for the trip status, and this 0 and 00, these are for the run status. Okay, and now this 4, 4, let's talk about this 4, 4. So we, as you can see, when we want to run this motor. So in my case, I have used this as a supply fan. So when there is a fire in the building, okay, the fire will trigger this VFD. Okay, so what I have done, in the 12 number terminal, as you can see, in the 12 number terminal, I have connected a cable 4. So this 4 means when there is a fire in our building, the fire will apply 24 volt to this terminal. Okay, so when this terminal have 24 volt, it will run the motor. So this 4 is connected to fire input. When the fire in the building, when there is a fire in the building, so the fire alarm will trigger this 4 terminal, and it have 24 volt. So once it has 24 volts, it will run this motor. So now in current case, there is no fire alarm in our building. That's why the motor is, or the VFD is not running. Okay, but once there is a fire in the building, it will automatically gets triggered, and once the 4 have 24 volts, it will turn on this VFD, and the 4 is connected to multi-functional input, that is digital input 1. Okay, so when there is a 24 volt in 12 number pin, okay, our VFD will run. Okay, and through this 2 and 3 pin, we will either increase or decrease. We can increase or decrease the speed from this pin, and we will see the feedback from this 7 and 8. And there is 2 relay, one for run status and one point trip status. So I have explained the physical terminals of the VFD, also the parameter. Now I will make a demo. I will run this VFD through a potentiometer, because now this fan will run when there is a fire in the building. But for now, we don't have any fire alarm in our building. Okay, there is no actual fire in the building, so this motor will not run. So what I will do, I will supply a 24 volt to this 4 number terminal, because I already explained you, when there is a 24 volt on the 4 number terminal, this will run. Okay, the motor will run, but now there is no 24 volts. Also from the BMS system, I can increase or decrease. I can give the command, I can give the speed, from which speed the motor will run. So in this case, I will give the command from the potentiometer. Okay, because potentiometer working will be the same. If you apply 10 volt through this potentiometer, it will run 100% speed. If 5 volt, it will run 50% speed. So by the voltage, by the variation of the voltage, you can vary the speed of the motor also. So at last, I will show you our DDC panel also. So let's move to DDC. Okay, so this is our DDC panel. In the DDC panel, we have a Siemens DDC PXE100, and we have lots of modules. Okay, so we have bring that cable, we have bring the BMS cable to this module, and this controller is connected to Siemens Decigo CC. Okay, and from the visualization, we are giving the value, we are giving the command to this. Okay, so let's start the practical demonstration. So I'll bring a clamp meter over here. Okay, we will check the voltage. Okay, so let's check the voltage in the 4 number cable. As I told you, when there is a fire in the building, this 4 is connected to this 12 number pin. Okay, so let me check the voltage in 4. So as you can see, let me show you. It's showing the voltage. It's showing 26 volt. Okay, and the other 4, this 4 is connected to the VFD. So this 4 doesn't have any voltage. As you can see, 2.4 volt it's showing. Okay, because reverse voltage is there. Okay, so that's why the VFD is off. But when I supplied a 24 volt to this pin, to this 4 number, okay, what it will do, it will run the VFD. Okay, so for this, I will show you. See, as you can see, we have a cable. Okay, we have a cable, this cable. So I will short that to 4, so that the VFD pin will have 24 volts. So once I short that 2 pins, automatically our VFD will going to be on. So let's check here. Let's come. So as you can see, I have connected a 4. Okay, once I sorted this, as you can see, the VFD gets on. Okay, as you can see, this relay for our run status. So once I sort from here, as you can see, once I sort this, see, as you can see, the VFD gets actuated. Okay, as you can see on the display also, in the display also it will show that the motor is running. Okay, once I remove, as you can see, the motor gets off and also the relay gets off. So when there is a fire in our building, the fire will trigger this 4 number pin and it has 24 volts. When it has 24 volts, it will run the VFD. Okay, so now I'll show you. Now I show you how we can turn on the VFD. Okay, but for now I will tell you how we can increase or decrease the speed of the motor by this potentiometer or from the BMS. Okay, BMS and potentiometer are the same. This potentiometer will apply the voltage between 0 to 10 volts. Okay, as per the voltage, it will increase or decrease the speed. If the voltage is 10 volt, the speed will increase. If the voltage go nearby 0, it will decrease the speed. Okay, so let's connect the cable and the potentiometer, and after that I will show you. Okay, so let me connect this cable. Okay, for now what I am doing, this is the middle one. Middle one is the output. Okay, this is the output cable, and this is the input cable. Okay, so the input cable I have connected. This is the input cable I have connected here. Okay, and here. So these two pins are input and this is the output. So in input we will apply a 10 volt signal. Okay, in the input we have to apply 10 volt. So we will take the 10 volt from this VFD. So for that purpose I will turn off the VFD so that it will not harm our VFD. So I have turned off the VFD and we will take this 10 volt from this 3 and 4 pin. Okay, 2 is the analog input, 3 is the ground for that one, and 4 is the 10 volt. Okay, over here this is the input cable. In the input cable I have connected to 3 and 4 pin. 3 is the ground pin and 4 is the 10 volt, which is coming from the VFD, and this cable I have connected to the input of this potentiometer. As you can see, these two cables are the inputs. So if we measure the voltage between these two terminals, it will show a 10 volt. Okay, so let me connect. I have connected one cable over here and one here. As you can see in the meter, it's showing 10 volt. Okay, so it means we are supplying 10 volt to this potentiometer, and from this middle pin we will get the output voltage. Once output voltage we can vary from this potentiometer. From the middle we will check the voltage. Okay, so as you can see, now it's showing a 0 volt. So let me increase the potentiometer value. DC. Okay, now it's showing 0 volt. So let's increase the potentiometer. As you can see, once we are increasing the potentiometer, it is increasing the voltage, and maximum it will go either 10 or 11. Okay, let's say, so it's going to 10 volt. Okay, so if we apply 10 volt, the motor will run 100% speed. Okay, so as you can see, if we decrease, see, it's the voltage is also getting decreases, as you can see. So what I'm doing, I'm removing this first number and I'm connecting this our potentiometer output to this. Okay, so I have connected our output of the potentiometer in the VFD, but the VFD will not run now. Why? Because there is no 24 volt output. What I'm going to do, I have short these two cables for now because there is no fire signal, so it will not run. That's why we shorted the 2-4 cable so that the other 4 have 24 volts. Okay, so now as you can see, now it's on. As you can see, if I make it off, it's off. When I make it on, it's on. Why? Because we sorted the fire, we sorted the 4 number terminal which is giving command to this VFD. But now you can see the speed is 0. Okay, why the speed is 0? Because from the potentiometer we applied a 0 volt signal. Okay, but if I increase the voltage, okay, what I will do, as if the voltage will increase, the speed will also increase. So let me increase little bit. So as you can see, I increase a very little bit, and in the frequency side, in the hertz side, it's increasing 0.2 hertz. So let me make it 5 volt. So as you can see, it's approx. See, as you can see, I am increasing the voltage from the potentiometer and it's increasing the speed also. As you can see, when it's full, see the speed is 60 hertz, means the full speed. As you can see the current consumption also, the current is 4 ampere for R, Y and B. If I make it down, as you can see, if I decrease the voltage, the speed is also decreasing, the current is also decreasing. Okay, see, I'll make it 50%. Once it 50% approx, so as you can see the speed is 20 hertz, 23 hertz and the current is 0.5 amperes. When I make it of 0, as you can see, I make it of 0, the hertz getting 0 and the voltage and the current is also getting 0. Okay, so in this video tutorial I'll show you how we can run the VFD ACS drive. Okay, how we can increase or decrease the speed either from the BMS or from the potentiometer. Okay, this concept is same. We are increasing or decreasing the speed voltage from the potentiometer. But if you connect it from the BMS, what you have to do? From the BMS you have to give the command. If you press in the BMS 50%, it will trigger the DDC and the DDC will supply a 5 volt to this analog input pin 1. Thank you.